Hello everyone, I'm Dharini here. In this video, we're going to develop a RNN model, that is a recurrent neural network model for stock price prediction. Before getting into it, let us know what RNN is. A recurrent neural network is a type of artificial neural network which uses sequential data or time series data. These deep learning algorithms are commonly used for ordinal or temporal problems such as language translation, natural language processing (NLP), speech recognition, stock price prediction, and image captioning. They are also incorporated in popular applications such as Siri, voice search, and Google Translate. Unlike traditional feed-forward neural networks, where the information flows in only one direction, RNNs have connections that allow information to persist. Without any further delay, let's get into the video. The main aim of this video is to develop a recurrent neural network model for stock price prediction and to predict the Google stock price based on time. For this, we are provided with a data set which contains features like date, opening price, highest price, lowest price, closing price, adjusted closing price, and volume. Based on the given features, we have to develop a RNN model to predict the price of stocks in future. Now let us move on to the implementation part. First, we need to import the necessary libraries such as NumPy, Matplotlib, Pandas, Minmax Scalar from sklearn, and sequential layers from Keras for building the neural network. Then we read the CSV file named trainset.csv into a Pandas data frame called dataset_train. Then we display the column names and the first few rows of the dataset. And this line extracts a specific column from the dataset_train data frame and stores it as a NumPy array in the variable train_set. Then we initialize a minmax scalar object with a specified feature range of 0, 1 and then scale the train_set data using this scalar. And we store the scaled data in the training_set_scaled variable. This block of code prepares the training data for a time series prediction model. It creates a sequences of 60 time steps along with their corresponding labels for each step. Then it converts these lists into NumPy arrays and reshapes X_train into a 3D array suitable for input into a recurrent neural network. Then we specify the length and the number of input features as shown. Now let us move on to the model creation. This code initializes a sequential model. It adds a simple RNN layer with 50 units and specifies the input shape as n features. Finally, it adds a dense layer with 1 unit, which is the output layer for regression. Then we need to compile the model with the Adam optimizer and specifies mean squared error as the loss function, which is usually suitable for regression tasks. Then we print the summary of the model. Then we have to train the model using the training data for 100 epochs with a batch size of 32. During training, the model adjusts its parameters to minimize the specified loss function MSE using the Adam optimizer. Then we again read a CSV file named testset.csv and into the pandas data frame called test. Then this line extracts a specific column from the dataset_test and stores it as a NumPy array. This line concatenates the open columns of dataset_train and dataset_test vertically and stores the result in a new data frame called dataset_total. The shown block of code prepares the test data for prediction. It scales the open column of the dataset_total using the previously initialized minmax scalar SC. Then it creates sequences of 60 time steps for the test data and reshapes it into a suitable format for the model. Then this code uses the trained model to predict the scaled stock prices for the test data. Then it inversely transforms the predicted scale prices back to the original scale using the min-max scaler to obtain the final predicted stock prices. Finally, the print, that is the shown code block, plots the real test data along with the predicted stock prices, that is the predicted Google stock price, against time. The plot visualizes the predicted stock prices compared to the actual prices. This is all in this video. Thank you for listening.